see the types of relations. Let A be any non-empty set. A relation R is given. It means any kind of relation is given. We know that then the relation is always subset of A cross A. The first type of the relation is a reflexive relation. So we have to remember the word reflexive. It means one kind of reflection. Element connect with itself, that means reflection. For every A belongs to A. Remember here the word which I mentioned is that every element from set A. So for every A belongs to A, if A is related to A, it means an element related with itself, then the relation is said to be reflexive. In mathematics this is possible. For example, in a set 1 is related to 1, 2 is related to 2. So a relation between elements with itself is possible. So if this kind of all elements are there and all elements connected with itself, then the relation is said to be reflexive. This is the first type of relation. Second type is symmetric relation. For given every AB belongs to A, if A or B, it implies B or A. See here, this is a conditional statement. You know that this is implication. Implication means conditional statement. One condition is given. Condition is what? If A and B are related, it implies B and A are related with each other, then the relation is said to be symmetric. It means what? Suppose in any relation 2, 3 ordered pair is given, then there must be 2 types of ordered pair is there. Then the relation is said to be symmetric, otherwise no. Third type is transitive relation. For every ABC, now here we need 3 elements, A, B and C. For every ABC belongs to A, if A is related to B and B is related to C, it implies A is related to C. So again this relation is conditional. See, A and B and C, both ordered pair are related with each other. It implies this A is directly related to C. It means I want to say that A and B are related to each other, C. That after this B is related to C, then A must be related with C. That is our requirement here. So A is related to B, B is related to C. It implies A is related to C. Then the relation is said to be transitive. Here we have to mention one important thing, that suppose 1, 2 and 2, 3, these 2 ordered pair are given in any relation, then 1 is related to 2, 2 is related to 3, then there must be one ordered pair, 1 is related to 3 should be there. Then the relation is said to be transitive, otherwise not. Now let us see several examples related to it. I mentioned here one set. A is 1, 2 and 5. It means this set is non-empty set. We know that relation is always defined on non-empty set. Following relations on A, our question is the relations are reflexive, symmetric or transitive. This kind of question can be asked in 1 mark MCQ. So see, first relation I write that 1, 1, 2, 2, 5, 4. Now let us see how we decide that. See, 1, 1, it means 1 connect with itself, so is reflexive. 2 is connect with itself, 5 is connected with, but only 1, 1, then we cannot say that is reflexive. 1, 1 is there, 2, 2 is there and 5, 5 is there. That's why the relation is reflexive. So this is reflexive. So this is reflexive. Now let us see what about symmetric. Symmetric means what? A is related to B. It implies B is related to. It means A is connected with B. Then we have to check that B is connected with A or not. So see how we decide. 1, 1, then its opposite ordered pair is also 1, 1. It means if we may write in reverse ordered pair. So 1, 1, then it is again 1, 1. 2, 2. Let us interchange this both elements. Then again the ordered pair should be 2, 2. 5, 5. If we interchange in both elements, then again we get 5, 5. So this relation is obviously symmetric. Now the very important thing is, what about transitive? We know that transitive is the relation where A is related to B, B is related to C, then A is related to C. Now see here, 1 is related to 1, But now this 1 is not related with any other element here. It means we break the chain like as corona. 1 A comma B and B comma C, then A comma C. But we know that here 1 comma 1, now this one is not connecting with any other element. So that's why the relation is identical. Similarly, this relation is also identical. Third relation is also identical. So if all ordered pair are identical, then it is obviously transitive relation. So this is one interesting example. So this is transitive also. So is transitive. Let us see now one more difficult example. Second example. Okay, before that I am saying that how many examples I will give. You can easily say that there are 3 elements. So number of relations are 2 raised to 3 cross 3, 2 raised to 9. It means 512 examples. So I can give you 512 examples. So at least 3 or 4 examples let us see. So R to the second example is 1 1, 2 2, 2 5 and 5 2. Let us see now what happened. See here, 1 1 is there, 2 2 is there, but 5 5 is not there. That's why the relation is not reflexive. Why is not reflexive? The definition says that for every element, an element connect with itself, then the relation is reflexive, otherwise not. So 1 connect with 1, see, 2 is connect with 2, but 5 is not connect with 5. It means 5 5 is not there. That's why the relation is not reflexive. So is not reflexive. I write the reason also. The reason is what? 5 is not related to 5 in this example. So is not reflexive. What about symmetric? Symmetric means what? A is related to B, then B must be related to it. Now see, 1 related to 1. And if we interchange this 1 to 1, then again we get 1 1. So is there 2 comma 2. If we interchange the order, then again we get 2 comma 2. Okay, 2 comma 5. If we change the order, then we get 5 comma 2, which is already here. See, similarly 5 2. And interchanging the elements, then you get again 2 5. So that's why the relation is symmetric. So is symmetric. Now the important part is transitive. See here, 1 1 is identical ordered pair, but 2 2 is not identical ordered pair. Okay. See here, this 2 is carrier of corona here. We may say that 2 is connect with 2. Now these 2 again meet with 5. So 2 2, 2 5. Then there is 2 5. But 2 5 is already there. See, read it as 2 2 AB. It means we may say that 2 is connect with 2. Now this 2 again connect with 5 as per the next ordered pair. See here. So we may say that A to B, B to C, then there must be A to C. A to C means 2 must be connected with this 5, but it is already given. So you think that this is transitive, but is not transitive. Why? Let us see one more connection here. Is also not transitive. Why not transitive? Let us see. The reason is very clear. See here, 5 is connect with 2. 5 is connect with 2 here. See this ordered pair. 5 is related to 2 and this 2 is related to 5 also. This ordered pair. Read it as A. See here, A is related to B and B is related to C. There must be A is related to C. Then the relation is called transitive. Now see here what happened. 5 is related to 2. It is obvious. These 2 again related to 5. But this 5 is related to 5 here. Answer is no. See here, 5 types of ordered pair is not there. 5 2, 2 5, then 5 5. But 5 types of ordered pair is not in this relation. So the relation is not transitive. It is very obvious. Now I will give you one interesting example. Okay, so here this example is over. Now I will give one last example to you. Let a relation is this. Relation R is XY types of ordered pair. XY types of ordered pair where X is wife of Y. X is wife of Y. So now let us see what happens. This relation is reflexive or not. If the relation is reflexive, then XX, reflexive means what? An element connect with itself. Now just read it as it is a very interesting thing. X is wife of X. It means a lady is wife of itself, but is not possible. So here X is not related to X obviously. It means therefore the relation R is not reflexive. It is very obvious that is not reflexive. Okay, now XY types of ordered pair suppose is there. So if X R Y, then we may easily say that Y is not related to X obviously, because X is wife of Y. It means that now Y is not wife of X. Y is husband of X. It is very obvious. So that's why X is related to Y, then Y is not related to X here. So therefore we may say that therefore R is not symmetric also. So R is not symmetric. What about now transitive? Let us see. So if X is related to Y and Y is related to Z, let us make the chain XY and YZ. But XY and YZ chain is not possible. See, X is wife of Y now. It means Y is, what about Y? We may say that Y is man here. Now how can we say that man is again wife of another Z? Because man must be husband of another Z. So that's why X and Y is a relation, or XY is in relation, then Y and Z relation, the relation is not possible. So that's why what we may say that, we may say that XRY is identical ordered pair. And we know that if identical ordered pair, then we may say that this relation is transitive. So therefore the relation R is transitive here. So this is the thing that, so this relation or this interesting relation is not reflexive, not symmetric, but is transitive. So it's very important question. So this is the end of the topic, and now in homework you can solve all the related example of exercise 1.1 in the chapter. There are 10 different kind of example. You can solve yourself, and that is your today's homework course. Okay.